Hey dev friends, welcome to Hello Obby. Today we're going to learn how to make our own platforming level and modify the character's movements. I'd like to start by taking you through a walkthrough of what Unity can do. When you first open the template project, you should see something like this. There's a lot of windows, and let's just go through them one by one. The main window here is the scene view. This shows you everything that is loaded in your current scene. If you right-click and drag, you can look around, and you can even fly around with WASD like you would in a video game. You can also hold Alt and click to pan around. And if you're locked onto an object, it'll make you circle around that object. Again, to focus on that object, I just hit F. As you can see, there are some objects in the scene, and you can tell what those are in this hierarchy window. The hierarchy window is your current loaded scene. You can see here I named it template scene. And in it is an outline of every object in its hierarchy. So under template setup is the camera rig, and the camera rig is main camera. In the template project, you have the camera setup. You also have character config, which is a quick way to modify the settings of your game. Again, you can see those details over on the inspector. The inspector window shows you everything for the currently selected object. So if I switch over to character spawner, you'll see we now have new information in the inspector. The character spawner is a default script we give you that just places a character in the scene. The floor is just a box that's been stretched out really big so that your character has something to walk on. And the sun is a directional light. If we toggle it off, you'll see it affects the scene. And if I rotate it, you'll see it changes the lighting. So let's walk through how to manipulate these a little bit. Every object in your scene is called a game object, and every game object has a transform. The transform specifies its position, rotation, and scale. If I click on the floor, and I set its scale to 111, you'll see that it's actually just a box. And this box I can rotate with the rotation tool. I used E, but you can also click the tool right here. You can also move it by using the move tool or pressing W. And you can scale it with the R tool, the R key, or the scale tool. You'll also notice that if I move it, it's moving along the plane of the object itself, not the world. To show that, I'm going to undo a little bit. So we have a floor. I'm going to copy and paste the floor so that it's a cube. Now we can see it. Okay, if I rotate this and I move it, it's moving along the plane of the cube itself. If I want to move it along the world, we change this in the top left to global. Now the axes are global, meaning I could move it along the floor very easily. In a similar fashion, you can change your pivot point to either being the pivot, which is the actual center of the transform, or the center of the graphics. So if we had, let's say, an empty object holder, and we placed the cube on it, even though I'm clicked on holder, which is over here somewhere, my axis, my pivot point is now around the visual object. If I switch back to pivot, you'll see that there's the actual pivot of the transform I have selected. So now I can rotate the cube around this axis, or I can rotate the object around the cube. So that's what transforms do. Let's take a look at what else we have going on here. The camera object is what is going to render to your scene. You can see there's a lot of settings here you can modify. The field of view affects how objects scale into the distance. The near and far planes is how far the camera can see. And the most commonly used things you'll want are post-processing, if you want to have effects happen at the end of the rendering. If you don't need shadows, you can turn this off for optimization. If you want a UI camera that renders on top of everything, you could make an overlay camera that plays on the stack here. And if you want a solid color for your sky, you could change the color right here. You'll notice that doesn't change the sky in the scene view, and that is because this camera renders to the game, not to your scene. So let's talk about the game window. The game window is over here, and you'll see the sky here is actually black. I'm going to drag the game window over so that we can see the scene view and the game view at the same time. If I rotate the camera, you'll see it updates what the game will see. So if you ever find yourself looking and not being able to control the camera, you're probably just in the game window instead of the scene. Another window we haven't talked about is the project window. The project window holds everything about your project that exists on your computer. So all of these things are actual files. If I right-click it and go Show and Explorer, you'll see that this is actually a file in your folder structure. This is important because whatever you make for your game, you're going to make in the project, but it won't exist in your scene until you actually place it somewhere in the hierarchy. So for example, if I made a script that moves a box, speaking of attaching to a game object, Unity uses a component system. If I click on the character config, you'll see there's a transform component. There's also a character config setup component. This is a script. If I click this, you'll see that it's a TypeScript file. This TypeScript file has been added to the game object. The game object now has a component that runs that script. There are a lot of different types of components that Unity uses. Unity built-in ones will use this button. So if we say I wanted a box collider, now this object can detect things in the physics engine just by adding this component. I'm going to remove this component though, we don't need it. Personally, I feel like the project window takes up a lot of space, so I'm actually going to show you how to switch it into a one-column layout. Now it is organized very similarly to the hierarchy, and in my opinion is much easier to navigate. We can also drag another window now that we have space. This is the console window. This outputs all the information from the game, and if you're writing code, you can print messages to see in the console and make sure things are running. Let's hit the play button and see what happens. You can simulate your game by hitting the play button at the very top. It will automatically switch to your game view and start loading into your active scene. Hey, there's our character running around. If you ever find yourself confused by the camera position, there is a scale factor here that can surprise you. Like, why did my camera break? All you gotta do is drag this back out to see your full window. If you want to change the size of your window, there are a few settings right here. You could have it be a free aspect where it just does whatever your window is. You can also preserve an aspect ratio. And if you want to output a specific pixel size, you can do that as well. You can also make your own with this button right here. Now that we have a little understanding of how Unity works, let's see how to build our first game. In the hierarchy, go ahead and right-click and do Create Empty. This makes a new game object, and as you can see, a game object comes in with a transform. The transform contains its position, rotation, and scale. This is an empty object, meaning there's nothing else on it. It's not going to render to the screen. It's not going to do any code. It's just empty. But we're going to go ahead and give this a name called Mesh or whatever you want. So that we don't mess with anything that was in the template project, I'm going to select all of the game objects that already existed, right click, and do Create Parent. This will create an empty object above all of the transforms that we had selected. You can see if I move this top layer transform, it moves everything under it. All right, now that we have that a little organized, let's make something in our mesh object. I'm just going to clear out the transform, meaning move its position to 0. And then in the hierarchy window, I'm going to right click 3D object cube. This will place a cube under the empty transform that we made. By default, this cube is 1 by 1 by 1 units big. If you can modify that, let's pretend we want to make a platform on the ground. We scale it down, we try to eyeball it down onto the ground, but that's not as accurate as we may want. You may notice that the pivot point of the cube is actually in the very center of the cube, which makes it hard to snap it to the floor. There's actually something we can do about this. Since our cube is a child of the empty object we made, we can set the empty parent to be exactly on the floor, and then move our cube to be 0.5 upwards, since that's the half height of the cube. Now if we click on our empty object, you'll see that the pivot is actually perfectly on the floor, and if we scale that empty object, the cube will scale based on that pivot point. Now we can have a platform that is always touching the ground exactly how we want. I'll go ahead and reset these transforms. So far we've only talked about position, rotation, and scale. But another very common use case is wanting to change the color of this cube. If all you want to change is the color, it's really easy to do. You don't even need to make a new material. The default material is lit, and we're just going to add a component called material color URP. So if you click add component and start searching, you'll see material color URP, click it. And now you have a variable that you can change on the fly to whatever color you want. This works in the scene view. You can also modify the color in code to have it change during the game. So you could have an animated color on your object. Let's push play and see what happens with our cube. Alright, the character collides with it. They walk up onto it and fall off of it. And we see it locked at the 0, 0, 0 of our world. Let's say that we don't want the character to walk on it, that it's just a visual. But we still want to detect when the character interacts with it. So if I turn off the box collider, the character no longer walks on top of it. It will just be a visual. If you want to say, do something in code when the character walks on it, but you don't want them to collide with it, you can enable your collider and mark it as is trigger. Trigger means that it will still run in the physics engine, but it will not stop other objects from moving through it. Another important note about the physics engine is that if you want an object that has a collider to move in your scene, you always need to add a rigid body. A rigid body is one object that interacts with the physics scene. You don't need it if you just have a static object that's not going to move. But if you do want your object to move around, just add a rigid body, and in this case, apply gravity, and you're good to go. It is possible to modify objects in scene view while the game is playing. And if you actually move this cube around, you'll see some strange artifacting. The collision box is moving separately from the visuals of the box. This is an interesting problem that can come up when you have nested transforms. Our top layer cube has skewed scales, non-uniform scales, and our rigid body is actually on the child object, the cube. So we're going to move that rigid body to the top of the hierarchy so that it's actually the whole object that's moving. The rigid body will automatically use the collider from the child object, so you can leave it there. And the last thing that we want to set up for this object is to make the cube uniform and offset by 0.5 so that we can have our platform again be scaled off of the floor. I'm just going to move it up to make it easier to see. And let's raise it up so we can see it fall. And if you take a look in the scene view, you'll see now that it's not warping like it was before. It's worth noting that if you do rotate around this cube, you will see that warping effect. And this is just, again, because the parent cube has a non-uniform scale, so if you rotate something under it, the transforms actually do get skewed, and the colliders cannot. But as long as you move the parent transform, you are good to go. Alright, let's set up our first platforms for our character to jump on. I'm going to go ahead and make a cube and zero out its transforms. I'm going to create an empty parent so that I have an anchor point for the cube. And I'm going to call this one platform. I'm going to move my cube up by 0.5 so that my platform can be attached to the floor. There we go. Now you can move and scale this platform however you want to lay out your obstacle course. If you hold control while moving, you will snap to the grid. If you look at the top of the scene view, you have different options for how snapping works. You can change the size of the grid for both position and rotation and scale. And if you enable snapping, now just when you drag anything, it will automatically snap to that grid size. Alright, so I'll reset that back to 1 just for convenience. And now we can place our cube in the exact positions. I'm going to move my block forward a little bit and make it nice and wide so it's easy to jump on. You can easily copy and paste with Control-C, Control-V. You can also do the shortcut Control-D, which is duplicate. I'll just make a few platforms at varying heights. You can do that by scaling the Y. Make a nice gap to jump over. And then I actually want to make a platform that cannot be jumped up onto. Alright, so let's check that out and see if it works as expected. We spawn in, we see our platforms. You can jump onto them because they have box colliders. And let's see if I can jump into this final platform. Ah, it's too short. So we're going to have to move this one up. I'm going to grab the top level transform and scale it up nice and high. Okay, definitely cannot reach that. But you'll notice if I stop playing, the cube goes back. This is because when you edit things in play mode, you are not actually modifying the scene, you're modifying the loaded built scene. So when you stop playing, all of those changes actually go away. If you want to preserve these changes, it is possible. So I'm going to scale this up again and find a good height. And then I'm going to right click on the transform component of that cube and hit copy component. This copies all of the values of the component. And then when I stop playing, I can go back to that platform and paste those values. Now I have it exactly how I wanted it during runtime. Alright, so now we have a platform that we can't get up to. I'm going to select all of my cube objects and add a material color component so that we can change the look of it. I'm going to make our tall one red to indicate that we can't jump on it. And you can set these to whatever you want, it's just for fun. Setting the material color is useful, but what if you want more control? What if you want the platforms to be shiny or to have a texture? You can do that by making a material. If you go to your project view and right click on a folder, you can do create material, and this will make a new material in your project. You can set up that material however you want, change how it renders, add textures, change colors, and if I apply this material here, you'll see that it is in fact updating. I have render backface on it so that you can really see the change. But obviously you don't want that. You can also set the material by clicking on the material in the component and searching for a specific material. Alright, that looks a little crazy, so let's go ahead and switch the render face to front, which is the default. And let's crank up the metallic and smoothness so that you can see it be a more metallic platform. Great, we'll call that good. Now that we have some platforms, that gives us a good starting point for the next time. If you want to add a bounce pad with custom code and new character settings, follow along in part 2. Thanks, friends.